Is a video tutorial on trigonometry with radians. When calculating using radians, all concepts remain the same. However, you must ensure that your calculator is in radians mode if you intend to calculate using radians with your calculator. However, it's best to utilize exact values where possible and not rely on the calculator whenever we can. With that in mind, let's learn to use the calculator in radian mode. So first, to activate radian mode, we need to do that in the menu. So mine looks kind of different to yours, and even the picture that I'm showing you may look different, but overall we need to get to that setup menu. The menu looks kind of like this, so let's do that here. Shift, or second function, mode. As you can see, there are two options here. 3 is degrees, 4 is radians. Obviously for this, we want it to be in radians, so we're going to press number 4. And there's that R for radians here. If ever you're going to go back to work with degrees, make sure that your calculator is in degrees mode. It should show that letter D on your screen. Well, now that it's in radians mode, let's do some calculations with radians. Here we go. Let's solve the pronumerals in the following. Answer in radians for angles. Well, let's answer first for theta. I'm going to be using cosine for theta here. So cosine of theta equals 5 on 10. Theta equals the inverse cosine 5 on 10. And now, because our calculator is in radians mode, if we just input this, shift mode, 5 on 10. There we are. It gives us the answer of 1.047 radians. Okay, let's do this one more time for phi. Let's solve this for phi. We can use any trig ratio that we want. For this, I'll just utilize tan. Tan of phi is equal to 5 on 5 root 3. Phi is now equal to the inverse of tan 5 on 5 root 3. Inputting this into our calculator, inverse tan of 5 on 5 root 3, 5 root 3, close bracket, and equals. This gives us 0.5236. 5236 radians. As you can see, it's very much the same when we calculate using degrees. Now, however, take note that I put a little note here, and the reason why I wrote that is when we can, we should utilize exact values. So for those of you that saw these as exact values, you would see that these radians are rounded off to a certain degree, certain decimal value. So let's take a look at what happens when we use exact values. This step here, cosine inverse of 5 on 10 is actually 1/2, so half. And as we know, that is equal to 60 degrees. And if we convert this into radians, 60 degrees is equal to pi on 3 radians. Now, just to prove the comparison here, we do pi divided by 3. That value should be equal to 1.07. There you go. 0.0047. So it's actually the same thing. All right, so you should really utilize exact values when you can. This is actually an exact value as well, but I'm going to leave it for you to solve yourself. Let's do this one more time. Let's solve this using the trigonometry again in radians. Let's solve first for a. To solve for a, let's use tan. Tan of pi on 6 is equal to opposite 7 over adjacent a. Solving for a, we get a is equal to 7 on tan pi on 6. Because our calculator is in radians mode, we can just solve this. This will give us 7 on tan, another fraction, pi on 6, close bracket. And this gives us that the length of A is about 12.12, and that's going to be in, I guess, centimeters. That's 2 decimal places. 2 decimal place values. Let's do this one more time for the value of B. To solve for B, let's use sine. Sine pi on 6 is equal to 7 on B, opposite over hypotenuse. B, let's make some more space actually. B is equal to 7 on sine pi on 6. Utilizing our calculator here, going to be 7, whoops, what happened there? Try again. 7 on sine pi on 6. Oh, and that's exactly equal to 14. Now, if you're wondering why this gave such a nice number, let's do this one more time using exact ratios. And again, you should utilize exact ratios whenever we can. Let's do this with sine. Sine pi on 6 equals 7 on B. For those of you that saw, sine pi on 6 is sine 30. And sine 30 is equal to half is equal to 7 on B. Solving for B, cross multiplying, we get B is equal to 2 times 7 equals 14. So while it's good that we understand how to utilize our calculator in radians mode, we mustn't forget utilizing exact ratios for trigonometry. That's the end of the examples. Hope that gave you an insight in using the calculator in radians mode. Hope to see you in the next video. Best of luck.